Good morning, everybody. Hector Ubinas from San Diego Gas and Electric. Definitely excited to be here today and share what we're doing with drones. I was a prior military guy before working over here with San Diego Gas and Electric. So my first thought of when I saw the job rec come out was, why is a utility using a drone? Didn't make sense to me. So really quick, I went over the introductory slide, but I will talk on kind of basic history of what we've been doing with drones, and then talk about currently what we're doing and what we're looking forward towards in the future. I didn't realize, and maybe many of you don't, we do a lot of, besides providing that power, we have to inspect our lines, inspect our infrastructure. A lot of that is done via the air, or as you can see in these pictures, a guy on a bucket truck or somebody actually climbing up a pole. Back in 2014, when we first started using drones or thinking about how we can incorporate drones into the company, one of the big things was safety, right? Not keeping a guy up on the tower when he doesn't have to be up there necessarily, or on the bucket truck, or even in a helicopter. If we can keep the human down on the ground, that provides a huge safety margin for our employees. Efficiencies, which I'll talk about in a little bit later on, but we have identified some efficiencies where drones have made work either quicker or, in this case, cost effective as well. And then in California, as we all know, we're pretty environmentally sensitive, right, as a state. And so instead of putting a truck in the middle of the forest to go check a pole or flying out a loud helicopter, we can put in a drone, which is a lot quieter, smaller footprint, or doesn't even touch the ground potentially, and not have an environmental impact. Some stats here. We were the first utility to get UAS experimental airspace. So this is back in 2014. This is prior to Section 333, obviously prior to Part 107. This is under 8130, I believe, the FAA order. We had to apply for this experimental airspace. And we were using this little guy right here, which is the sdg&e. It's a U.S. Army drone that we adopted for our inspections. Actually, interesting enough, somebody asked about city police. We actually donated, I think, two, right? To Chula Vista PD, and they've been using that. I don't know what capacity, but they have that in their arsenal there. We did also get experimental airspace for the quad rotor UAS, and then the airworthiness certificate for this little guy right here. So this is the start. 2014, about mid-2014, we're playing around with the sdg&e. If anybody's familiar with it, it's just a little rope or little UAS, maybe about a pound, 2 pounds. Extremely unstable, so it buzzes around like this. It's not like your DJI products now. So you can get real seasick as you're looking at the camera or the video footage, trying to see what, inspect a pole. So it kind of got us started, but then we started looking at, all right, what do we want to move towards? You know, what's out there in the market? So we shopped around a little bit, came with, towards the end of our R&D phase, hey, you know what, let's look at the Inspire. And then another one we looked at a lot is the Vapor 5.5, the Pulsar, which is this helicopter right here. I'm sure everybody's familiar with the Inspire, a little larger, maybe about 5 to 7 pounds or so, quad rotor. And then this guy here, if anybody's seen this, is actually a very large drone on the order of several thousand dollars, and probably the size of this table. Huge footprint, very loud, and it's great for carrying. What we wanted it for was for LIDAR. So we want to cover everything that we can do with drones. Not only pictures and video, but we want to be able to do LIDAR, photogrammetry, so let's look at everything. What we found out through R&D is that's not maybe the best business case for us as a utility, because we don't have the expertise in-house to fly all these expensive sensors and equipment. So we really looked at, going into 2017, let's get something simple for us, right? Let's keep the basic picture taking that we want to have in-house as a capability, when we can use a little thing like a Mavic or the Phantom 4. Easy to fly, the sheriff mentioned inexpensive, so if any of our employees that are flying it have an accident or crashes or whatever, it's not that huge of a loss. And then we'll leave the heavy lifters like the M600s, or you saw there earlier the Pulse or the Vapor 5.5 to the experts. And we'll look out and contract to those folks. They know how to use the LIDAR, they know how to process the data. We'll just focus on taking pictures and video. So currently our fleet has in-house, we do have those Inspires. We don't really use them that much anymore, but we have 4 of the Mavics, and I believe we have 6 of the Phantom 4s right now. And this kind of leads into the current operations in our business model. So we have a two hybrid set, I guess, a 2-tier set. We have our aviation services department in-house, which our internal employees fly those Mavics, those Phantom 4s, and the stuff that they're going to be using it for, the use cases are visual assessments, like I mentioned earlier, looking at the tops of poles or infrastructure, thermal assessments. That's what we keep the Inspires around for, because we can put the XT camera on that and get some good IR data. A lot of pre and post construction. It's actually been a hot topic as of late for us, kind of taking a picture or a record of what an area looked like before we even showed up there, and then what it looks like afterwards when we leave. vegetation management, environmental, a lot of avian nest clearing, basically, making sure that we're not disrupting any protected species if we're going to be doing any work in that area. So we'll send the drone up to take a look into the nest, see if it's still active or not. And like I mentioned, training for our own internal employees. All that's easy to accomplish with these little drones that are safe, less risk if they do hit a pole or a wire, won't go phase to phase. For the heavier stuff, the more complex stuff, we're going to look to the contractors. So look with this M600, we'll use them for the LIDAR survey, like I mentioned. Photogrammetry, not necessarily, doesn't require a heavier or a larger payload, but it's just a little more expertise-wise with the software processing, which we in-house do not currently possess, so we usually contract that kind of work out. Large-scale environmental projects, and just large-scale projects in general, where we only have 2 or 3 folks in-house right now that they have other jobs that are trained as well as pilots, so it's kind of a side gig that they do. We don't have any dedicated pilots in-house. But then when we need something where it's going to be covering spans and spans of either area or poles where 3 people can't cover that, we're going to look to contractors to help us out with that. Okay, so now we're going to look at some pretty pictures. What are we doing? So visual assessments. This was taken, I think, with an Inspire, actually, a couple years ago. But you can see we get a clear bird's eye view. Zoomed into the pole top, you can see actually where the rot's occurring right there with the woodpecker damage as well. And this has kind of been something we've been really focusing on, is how can we make this beneficial for us as a utility. Because right now the way we're doing business is either helicopters are flying out, like I mentioned earlier, or there are ground patrols, or our linemen are out with binoculars. So we tested this in different environments. We went to La Jolla, went out to Ramona, out to the backcountry, and in some environmentally sensitive areas, and trying to find out, all right, is there a benefit? What's the cost going to come out to? Where is it that the drone actually beats the person on the ground or beats the helicopter? And what we came up with actually is certain scenarios right now with regulation limitations, i.e. beyond visual line of sight, it's going to limit us to what we can actually, where it'll be cost effective or beneficial. So for example, we're in La Jolla, where you can have ready access to the street, or sorry, the poles are readily accessible from the street. In that scenario, the lineman in the truck can easily walk up to each pole, get a good look at it, get a good look from the bottom, use his binoculars, make his assessment, and keep on going. He'll be a lot quicker and just as accurate as if we fly the drone down the street and go, let's say 1,000 feet down the street, then we have to stop, we have to reposition, pick up again, change the battery, go up again, and then we still have to have that lineman or that qualified person actually review that footage afterwards. So there's some time consumption there. It didn't work out. It was actually cheaper and quicker to do it on foot, the traditional method. Now we fast forward to another area of La Jolla where it's in the canyon areas behind the lands, environmentally sensitive area, a lot of vegetation, requires hiking through some pretty dense terrain, and actually our environmental group to clear out an area for a guy to walk through. That's where the drone is able to pick up and just fly. I think we did 17 lines that day in a matter of a couple hours, where the lineman that was with us said it would have taken him probably 2 to 3 days to just hike through all that foliage to get up and look at the poles. So that was a huge win for us. Same thing when we went out to the backcountry as well. We're like, all right, let's look at another line of 25 poles. How is this going to compare where we do it traditional method, either via a helicopter or a manned foot, and compare that to the drone? What we saw is when you go more than, we're looking at 3 to 5 miles worth of lines, the helicopter is going to be just that much. It's going to be so much quicker because he can cover that in less than an hour. Whereas a drone going out, taking that kind of information, it's going to take hours, maybe even a day or 2 to get all that data information. And compared to the guy in the truck, depending on where that is, that's where it comes in with the terrain. If it's accessible via dirt road, he's still going to be quicker. But if it's somewhere where it's hilly and mountainous, it's definitely going to be beneficial to the drone. So it depends really on the scenario. What we found out is kind of where that balance is and what we want to apply it towards right now. Obviously with beyond visual line of sight, if that ever does, and I believe it will eventually get relaxed, and the technology can support going long distances, the drone could potentially replace that helicopter in the long run. But right now the helicopter can cover too much ground so fast that the benefits outweigh the cost. Thermal assessments, another great tool or application for the drones. We've seen this just for patrolling hotspots. Similar scenario applications with or benefits with the visual assessments as far as where we can apply it. So what we've been doing is basically whenever there's a 1 pole or 2 pole kind of set where it needs to be looked at, we've had some trouble, we'll pull out the drone, We'll put the thermal camera on the Inspire and we'll look at it. It's got a radiometric sensor, so we can actually look at the individual pixel and degree, and our thermographer can look at what's the temperature and make his assessment. But if it's patrolling a long line of poles, which he does a lot, especially out in the desert, the helicopter is going to be the better win right there, for right now at least. LIDAR surveying, this is probably where the most used case at the utilities right now currently. It's the biggest win. And this is actually a very pretty edited picture of a LIDAR survey, so it's not the raw cloud. But this is great because traditionally we've been using a lot of ground surveying or crews to get this LIDAR data. And when I talk to those folks, when they now started using the drone, they're just amazed at how quickly, like, this footage would have taken us days. We did it in a matter of an hour or two. Now, I say we as in the contractor is doing it. We're not doing it. But a lot of cost savings here because a lot of the time saved with this application. What this is used for, a lot of our engineers right now are using this stuff. So they're looking at, hey, we go out and construct a pole or a site. We want to see afterwards, how does this compare to the design that we'd submitted? So the engineering folks in sdg&e are the real customers for the LIDAR surveys. Okay, so what's next? We're all about innovating and trying to figure out how can we continue using this in the utilities. So we actually have a partnership with DJI where they've been coming out and working with the utilities as far as LIDAR and trying to develop some kind of LIDAR product for one of their future drones. Something that's going to be a little bit easier to handle with the simplicity of the DJI, but still give the quality of what we're looking for. We're also always looking for new use cases. So I mentioned up here sock line stringing, which is, if you ever wondered how do the actual wires get onto the poles, they're actually usually pulled from a helicopter on the bottom of the helicopter across the top of the pole. We're looking to see how we can potentially use a drone to do that as well. Obviously, you just start pulling it, and once it gets on top, we can have somebody pull the actual heavier wire, but the initial placement could be done via drone. We're also looking at emergency response, so thinking about fires. As soon as the fire comes up, if we can get up airborne, take a look for our infrastructure so our decision makers can make the right decisions on how we want to rewire the grid. And also gas sensing, because we are sdg&e, and we've focused a lot on the electrical side, but not so much on the gas lately. And so we're looking at now, hey, how can we look for gas leaks? And then I mentioned new systems and sensors, and somebody mentioned earlier M210, because we're real excited to get that. We actually have 2 on order. I think next month, August is when we're expecting them. And it's going to help out because now we can do 2 cameras at once, which everybody knows. So we can put in the XT with the visual camera and get IR data as we get visual data and survey our poles. This is something cool we kind of experimented with back in October. We're looking at change detection. You fly a drone over a set of wires, or in this case is a substation. They take a picture or collect data. In this case, this is LIDAR. And then you make a change, and then you fly the same path again. Can the software detect that change and bring that up? And the way you'd see this is later on in the field, broken cross arms, damaged transformers, that kind of thing. So this is a very basic, easy one where we had a switch which previously closed, and then we opened it, and we tried to see if the software could pick it up. And in this case, it did, and it was very easy for these large changes. But for some of the smaller stuff, like we simulated corrosion, or we backed off a nut, something like that, it wasn't yet refined enough. The process wasn't mature. So we're working with some different vendors to kind of test out their data analytics to see if we can incorporate that into our inspection cycle. And that'd be something we'd be real excited to see later on, because that would save us a lot of time and money. Instead of having to do our periodic inspections, we can do this with a drone. And then lastly, so this is another LIDAR diagram here. And what I wanted to highlight is, the whole beyond visual line of sight. So this is really key for us as utilities, especially we have miles and miles of power lines that go all the way out to the border. Whenever the regulations are relaxed, which is one big piece, the second big piece being the safety aspect, right? The see and avoid, and being able to effectively fly that drone without hitting anything. And then technology catches up with the quad rotor systems and the imagery. I think we could see this happening where it would capture LIDAR and visual and infrared all at once, and we can do all these applications that we do individually in one pass from essentially office, one of our places, and be able to get done with quickly. So this is what that kind of application obviously is years and years away, but this is kind of what we're looking forward to, and we're taking baby steps in that direction slowly, just with these smaller use cases, and then applying them as we can to grow that vision. And of course, the future also looks like the pizza delivery from the drone, which I'm excited for as well. So, kind of sped through that, but just want to make sure get time for some questions if there's anything out there.
We've flown some signals around some of Comet's smart grid deployment, and we experienced some pretty severe RF interference. Are you seeing any of that? And if so, how's that factoring into your plans as smart grid gets further deployed?
Yeah, no, we've seen it only a couple times, and it's when we got a little too close to the wires, or if we're in a very heavily, like a close to substation, especially where there's a lot of metal. So when we're in high voltage areas, we try to keep at least 15 feet away from the lines, and that has mitigated a lot of the interference we've seen. And normally what we saw first was the video would go out, so we knew if we're getting too close, if the video started getting out, then we need to back off before we actually lost control of anything. So we never lost control, we never had to fly away, thankfully. But we were able to tell right away as soon as the video started flickering in and out, like, okay, back off. But in general, 15 feet is kind of our buffer where we're keeping away from our lines. And that's been helpful. It's kept us from seeing any of that.
You mentioned several projects that you had sort of undertaken as an experiment to see whether it would work or not. Do you find that most of these are generated internally from your own group, or that you're approached by vendors that want you to examine the solution or adopt the solution?
No, that's a great question. Internally, we have our own internal folks come up to us and be like, hey, can the drone do this? What do you think about this? And then, we sit around like, all right, is this possible? Can we do this? And sometimes we've gone out to contractors and been like, hey, we either don't have the bandwidth or the resources to kind of figure this out, or we've tried and we've failed, or this is what we've come up with. I think you may be able to come up with something better, and we pitch it back to them. But a lot of this stuff comes internally as like, hey, what about this idea? And then we go out and do it.